Did you know, just like humans, atoms also form bonds to become more stable? Yes, that's right. They form what we call chemical bonds. These bonds are the invisible forces that keep atoms together, allowing them to form molecules. There are three main types of these bonds: ionic, covalent, and metallic. Each plays a unique role in the formation of molecules. So, in essence, chemical bonds are like the glue that keeps atoms together, forming everything around us. Now, let's dive deeper into these bonds. First up, ionic bonds. Imagine a generous atom donating electrons to another atom. This selfless act forms an ionic bond. The donor atom becomes a positively charged ion, while the recipient becomes negatively charged. Their opposite charges attract, creating a bond. Moving on to covalent bonds. Picture two atoms, not quite as generous, deciding to share their electrons instead. This sharing creates a mutual attraction to both of their nuclei, binding them together in a covalent bond. Lastly, let's talk about metallic bonds. Think of a group of metal atoms, each sharing their valence electrons with the others. These shared electrons form a sea that engulfs the metal atoms, binding them together. Each of these bonds has unique properties and roles, making them vital in the formation of different substances. But what influences these bonds? Stay tuned to find out. But what determines the type of bond an atom will form? Well, several factors come into play. The number of valence electrons, electronegativity, the distance between atoms, and the energy of the molecule all play a role. So the type of bond is not random, but is influenced by these factors. Beyond the main types, atoms can also form other bonds like hydrogen bonds, van der Waals forces, and dipole-dipole interactions. These bonds, although weaker, also play crucial roles in the chemical world. So, we have explored the world of atom bonding today. Can you think of how these bonds come into play in everyday life? Drop your thoughts in the comments section below.